So today we are going to create the Kubernetes cluster on the top of AWS account. However, we are not using managed service provided by AWS. We are using VPC and EC2 service to create a Kubernetes cluster. Now the method we are going to use, it's the same Kubeadm method. Okay, that is the basic fundamental method to create a Kubernetes cluster. The only difference is whatever we have done in our training, that is on premises. Here, the infrastructure component would be coming from AWS cloud provider. Okay, so we are using two services primarily to create a Kubernetes cluster. Correct? Now, the first service is called as VPC. Now, this is a virtual private cloud service, which is nothing but a networking service which is provided by AWS. Now, as I told you while discussing the architecture of the Kubernetes cluster, the network connectivity across the nodes are very important, because every worker is talking to the master is also talking to the workers. Correct? So the interconnectivity across the networks is very important, crucial part in Kubernetes cluster. Correct? So here VPC service will play a very important role over here. VPC will create a network, and here also we are going to create a dedicated network for Kubernetes cluster. Now technically it is recommended, if you have already have a VPC, if you have already have a subnet, okay, you can use that subnet to create a VPC. However, it is recommended to have a dedicated VPC to be created for your entire Kubernetes cluster. This is recommended method. Okay, so here in our practical demo, which we are going to use a dedicated VPC with a subnet of 192.168.100.0. We are making it very simple and straightforward. Okay, so this is the network CIDR which I am using to create my network. Correct? After you create a network, it is compulsory that we are supposed to create a subnet of that particular network. Now subnet means, technically subnet means what? Dividing your network into the smaller chunk. That method is called as subnet. Correct? Now here in our lab environment, we will create only one subnet. Subnet of 256 IP address. Either I do have an option that I can divide this 256 IP address into the smaller chunk. Correct? Now that is recommended method inside our production environment. Correct? But here in a lab environment, I will create a subnet only for single network. Correct? So after you create a subnet, for this particular subnet, there should be a dedicated route table. Means how the network would be communicated. Okay? That should be dependent on this route table component. So we should have a dedicated route table over here. So if any rule which I applied over here, that rule would be applied to all this particular subnet. Another component under the VPC is called as internet gateway, that is called as IGW. Now this is nothing but a internet connectivity to be available for your VPC. See, my masters and workers required internet connectivity, so he can download the images over the public repositories or the repository available over the internet. Now in that case, I need this VPC should have an internet connectivity. So that connectivity would be given to you by IGW. It is an internet gateway. You can say it's a logical modem. Okay. After that, I should have a security group. Now security group is a very important security component inside your AWS. You can say that security group is a host level firewall. Means which traffic is allowed, which traffic is not allowed. That is dependent on the security. So we will create a dedicated security group for our all cluster machines. So any change which I can apply into that security group, that change would be applied to all workers and master. In a production environment, it is recommended that for master you should have a separate security group, and for worker you should have a separate security group. But this is a lab activity, so if you can keep one security group, that is also fine over here. Correct? So this is the scenario to create a network for your Kubernetes platform. After you have done this, then we will use the service called as EC2 to create our nodes or workers and master inside your Kubernetes cluster. Correct? So you have to remember that this has to be done with the help of EC2 services. Now here the machine which we are planning to use for our lab environment is P3 medium, because at least 2 virtual CPU and 4 GB RAM is recommended for every Kubernetes cluster, even though if it is a test cluster, even though if it is a POC environment, minimum, this is the minimum recommended memory and CPU you require. So this is the overall architecture which we are supposed to use inside our Kubernetes cluster while building it. Okay, so now let's get started. So right now I already logged into my AWS account. I hope you are able to see. This is a AWS console screen which I am able to see it. If you can look into the right hand side, this is the region currently I am selected. Okay, now there is a one more option is available called as local zone concept they are introduced. However, we are currently working on the region side, so you would be able to see Mumbai is the region which I have selected. Means whatever infrastructure component which I would be creating for my test environment, that should be created under the Mumbai region. Okay, currently I am logged in as a user 1, that is a identity and access management user. Okay, so this is the user I am currently logged in. So I am a user. I got full privileges. Okay, I got full privileges on my account, so I can do anything. Okay, so I am not a root account, but I got a system admin privileges to be available with me, so I can go ahead and do any activity on my AWS account. There is no restrictions. Correct? So here is the VPC. So currently the VPC in Mumbai region, there is zero. Nothing is available. Earlier versions of AWS do have a by default one VPC that is called as default VPC. Nowadays they don't have a default VPC concept also available. You have to create your own VPC by yourself. Okay. So if I go to the VPC service, you would be able to see there is no VPC currently available. There is a button called as create VPC over here. Please click onto this button. Now here there are two options are available. Either I just want to create a VPC, or I want to create VPC, subnet, route table one by one in a single wizard actually. Then I should choose this option. But currently I would like to give you a very clean and clear instructions. So I will do it everything step by step, not in a single activity. So I just want to select VPC only at this moment of time. I would say my Kubernetes VPC. This is the name of the VPC. What CIDR which you are using it? I am using 192.168.100.0/24. So if we can carefully check, this is the CIDR value which I am getting. Okay. So you would be able to see that the default tenancy is a default one. Okay. Encryption, I do not want to provide any encryption at this moment of time for the VPC traffic. After that, there is a button called as create VPC. So your VPC got created. Okay. Now, if you can see that under this VPC, this is just a network which I have created. I will get the resource map over here. So this is the VPC. So after the VPC, what should I create? Subnet. Correct. So there is a button called a subnet over here. So you can click onto the subnet. There is a button called as create subnet. If you can click onto the create subnet button, he will ask you, please choose the VPC where you want to create a subnet. So I already have created this VPC. So automatically the associated CIDR is available over here. Now he's telling me, okay, tell me what is the subnet name which you want. I would say my Kubernetes subnet. Correct. I just want to create only one at this moment of time. But in real life, as I told you, you are supposed to create multiple subnet for high availability feature. The availability zone where this particular subnet would be associated, I would say AP South 1A So any machine which I will create into this subnet, that machine ultimately go to this availability zone. Correct? Now this is the IP address CIDR block of the VPC. Under this, how many subnet you want? I want only one. Whatever network is available, I would like to create a one subnet only. So I would simply say that 192.168.100.0/20. Correct? So how many total IP address I am getting in this subnet? 256. Okay. Out of that, how many are usable? 251. Correct? So I can create 251 nodes, workers and master with the help of this CIDR. I would say create subnet. So you would be able to see that your subnet got created. So if I go to the VPC, if you can see your VPC, okay, if you go to the resource map, you would be able to see under this particular subnet, under this particular VPC, the subnet got created. Now automatically you would be able to see there is a route table automatically associated for this particular subnet. So if I go to the route table over here, okay, I could use this same route table which is associated with your subnet by default, or else you can create your different route table where you can associate this subnet over there. So for example, to make it simple, I will create a route table. I would say my Kubernetes route table. Select the VPC over there. This is the VPC which I want this route table to be created. I would say create a route table. Okay. Now I need to attach the subnet into this route table. So there is a button called as subnet association. There is an explicit subnet association which I'm getting it over here. I would say edit explicit subnet association, choose your subnet, and I would say save association. If I go to the subnet association, this particular subnet is associated with this route table that is called as RTB. So if I go to your VPC, once again, if you go to the resource map, you would be able to see earlier it was connected over here. Now it is connected over here. So if you want, you can delete this particular route table. Doesn't matter. Correct? After that, we should have something called as internet gateway, as I discussed inside the diagram. Internet gateway is nothing but the internet pass through to get the connectivity inside the VPC. So I should go to the internet gateway and create internet gateway. I would say my Kubernetes hyphen IG. I would say create internet gateway. Okay. Now currently the state of the internet gateway is detached. I would go ahead and say attach the VPC. Choose the VPC, the one which we have created, and created the attach VPC. So once again, if I go to the VPC right now, this particular VPC do have a complete idea. The VPC got created, subnet is associated for that VPC, subnet got the route table, and internet gateway is connected to this particular VPC already. But one more thing you need to do it after connecting your internet gateway to your VPC. You need to go to the route table, go to your route table over here, which is associated to your subnet. Here you need to add the route for internet connectivity. Okay, you can see over here there is only one route is available into this route table, that is a local route table route. Correct? But here I need to go to the button called as edit routes. I need to add the route, and I would like to add the route for internet connectivity. So my destination should be 0.0.0.0/0, means over the internet. I don't know the destination IP address. So this is internet. If you want to go to the internet, to whom you should connect? You should connect to the gateway. And what gateway? This is the gateway you need to connect. So what I'm telling my subnet at this moment of time, I'm instructing my subnet, any machine within this subnet want to go to this destination, they should go where? The internet gateway. So they should pass their data packet to that internet gateway, and internet gateway is a pass through to get the internet connectivity inside my VPC. So this route table rule is very important. because based on this route table rule, your internet connectivity will get flowed, or internet connectivity will get flow inside your VPC. I would say correct. So you can see this route is very important. I said okay. So my network is completely configured at this moment of time. So you can see this is a bare minimum networking component you require. Bare minimum, correct? You don't require any additional things to be there. This is the bare minimum networking component you require. After that, I told you we would like to create a dedicated security group over here. So here I need to go to the security groups. Now, sorry, it is security group. Okay. So here currently there is a default security group is available, which is created by your system. So I would like to create a dedicated security group over here. I would say my Kubernetes security group. So you can declare it. This group is only created for Kubernetes. I just want to create a select the VPC. Now outbound traffic is by default allowed. Every traffic is outbound from that particular security group. Outbound traffic is allowed. Inbound traffic I need to attach the rule. So currently I will attach only one rule, that is only SSH traffic from anywhere currently allowed, because I would like to do the SSH to that machines, workers and master to do activity. So currently I would go ahead and execute this particular rule. I would say create a security. Okay. So only one rule is currently allowed. Only port number 22 traffic is allowed through this security group to the machine. Correct. Now let's go to the second part of our demo. Second part of the demo is very clear. I would like to create one master and two worker. That means I would like to create a machines right now. Now for creating the machines, we are using the service called as EC2. Okay. So what I can do it, I will go to my service called as EC2. Now be careful while creating your servers also. I will go to the dashboard. Okay. Currently only one key pair is already created. Now key pair is very important. Now key pairs are the authentication mechanisms which you are supposed to create before you create your EC2 instances or servers on your AWS. So what I have done, if I go to the key pair, now I already have the key pair created already, and I downloaded the private key for for this particular key pair on my machine. So if I create any virtual machine with the help of EC2 instance, and if I put the reference of this key for that particular machine, I can connect with my private key to that machine without any problem. So here I am already have created the key pair. If you would like to create a key pair over here, there is a button called as create a key pair. You can create a separate key pair for every machine, or you can use single key pair to be applicable to all the machine depending on your scenarios. Correct? Now to make it very simple and very straightforward, I only have only one key, and through that one key I am connecting to all three machines. Correct? So first of all, you are supposed to have this Kubernetes key. Then I will go back to the dashboard. Okay, I will click onto the button called as launch instance. Okay, now here how many instances which I want to create? I would like to create three instances. Okay, so I want to create three instances. The application and OS image should be Amazon Linux image over there. So if I go ahead and choose that particular image, it's a Amazon Linux. Now this is a basic image which we are choosing because this is very close to Red Hat, very close to the CentOS over there. Correct? Now Amazon Linux 2021, correct? Then I should use the instance type over there, that is called as T3 micro. Correct? Now here I told you I required that is called as T3 medium over there because that is the bare minimum instance which I require to create my labs over here or demo instance. So I will go for T3 dot medium. Okay, definitely it is going to cost you money. It's not a free tier, correct? So definitely whatever cost is associated with that, you would be able to get the real-time cost per hour over here. Okay, now here we do not require any charges to be given at this moment of time for this account because this is a trial account. So I'm getting some free tier available for T3 medium also. Okay, now here I'm choosing the key pair login. As I told you, I already have the key pair created. I'm choosing the same key pair for all these three instances created over there. Okay, now this is the very important setting. You can see that automatically the VPC is automatically selected over here because that is the only VPC which we have created, correct? But here there are small changes which I have to do it. Now you don't need to worry about the VPC because the exactly my Kubernetes VPC is selected. Automatically he's created the subnet because that is the only subnet which we have. So you don't have a choice. So you would be able to see the subnet is also got selected over there. Here this is the only change which I would like to do it. Auto assign public IP address. Now see, this is my trial account and I would like to connect to those virtual machine through the public interface. So here I need that particular options to be enabled. Now in your case, it might be not required. You guys can connect to your EC2 instance with the private IP address also because you have a dedicated VPN connectivity across your company network and AWS network together. So if you are connected through that particular VPN, you really do not require any public IP address to be enabled. Even though if it is disabled, still you guys are able to connect to your network or your guys are able to connect to your server with the private IP address. But in my case, that is not true. Correct? Second thing is security group, which is nothing but a firewall to apply for these three machines. So I would like to choose the existing security group, which we already created. I'm choosing that security group. And according to that security group, only port number 22 currently applicable over there. Hard disk size, which is nothing but 8 GB. We are just doing it for a demo purpose. So you would be able to see that 8 GB hard disk is also very good. So these are some advanced settings. We don't want to provide any advanced settings over here. Storage 8 GB, it's okay. Now you can see free tier eligible up to 30 GB, but we do not want it because we just want to create EC2 instances with a bare minimum configuration. Then I will go ahead and say launch instance over there. So you would be able to see automatically 3 instances would be created with the same settings, identical settings which we have done. Now if I go to the running instances at this moment of time, now all 3 instances are currently in a running state. These are the public IP address which I would be using to connect to those EC2 instances over there. Correct? Now these three machines got created. Now I would like to give some naming convention to display it purpose. So right now in this particular console, which machine would be act like master, which machine would be act like worker, I don't know. So if I would like to do that particular configuration here, I will decide this machine will act like a master machine. Okay, so this is only for display purpose, and this is would be my worker number 1. Okay, and this is worker number. This is just to see it on the console. This is the naming convention which we are supposed to do it. Now I would like to go ahead and take the remote of this machines. Remote means these are all Linux based machine. I got the public IP address available over there. These machines are properly connected to the network at this moment of time. So I will see this is the public IP address and this is the private IP address given by the VPC, correct? So whatever VPC created, you can see whatever range we are declared for the VPC and subnet, within that range one of the IP address would be allocated to your machine. This is a private IP address. Now you guys are able to connect with your machine with the private IP address. That is because of the VPN connectivity. I cannot do that. I require this public interface to be available with me. So what I will do it, I will copy this master machine. I will open up the putty session, put this IP address which is a public. I will go to the SSH auth credential. So here I need to go to browse button and I need to choose that key which is already saved on my machine. So the key is this one. I would say open. I would say open. I would say accept. Then I need to use the default user that is called as EC2 hyphen. Okay. So this is my master machine. I configured it over because this is I declare it as a master machine. So what I can do it over here, I will log in as a root user. So if I say sudo su hyphen. So whatever setting which I would like to do it, I can do it with the EC2 user, no problem. Then I need to make sure that every command should start with the keyword called as sudo, or I should use this particular command to switch to the root user, and I can do all the activity by the root user. So I will go ahead, go to the chain settings, appearance. Okay, I just change this. So this is my master machine. Now it is completely up to you. This is the by default host name of your all the EC2 instances, IP address of your particular machine. But if you would like to change that particular name, I would go ahead and do that. Now I logged in as my master, so I will change the host name of this machine by using this command host name ctl set hyphen host name. I would say master. If I execute the bash command, so the name of this particular machine is a master, correct? Similarly, I will take the another machine over here that is a worker one, copy the public IP address. I will open the putty. I will go back to the auth, credential, browse. I will go back to the same key, EC2 hyphen user. Okay. I just want to change the settings. Okay. I will say sudo su hyphen. Now I would say host name ctl set hyphen host name worker number. I would say bash. So this is my worker number one. Similarly, I will take the third machine also. Now I'm doing it step by step, so it would be very easy to understand what I'm doing. I'm not doing it everything parallelly. So I will log in to my third machine, SSH auth credential, browse, and go to that where say open accept one user. I will change the settings appearance. I will say sudo su hyphen host name ctl set hyphen host name. I would say worker number 2. Okay. Now you would be able to see that all my three machines are running. All three machines do have their host name set up properly. Worker number one, worker number two. After that, the first step that I know that the network connectivity across this machine should be properly configured. So if I try to ping this master machine with worker 1 and worker 2 and vice versa, if I try to do ping from worker 1 to master, they should be able to ping even. Okay, so if I go ahead and check the IP address, I'm talking about private IP address. Okay, so if I go to my worker number 1 and if I say if config, the private IP address is this one for my worker number 1. If I go to worker number 2, this is my private IP address. Correct? So if I go to my master, if I say ping, what is my private IP address? This is my private IP address. Now, am I able to ping with the IP address of it? The answer is no. Okay. If I try to ping my worker number 2, sorry, worker number 1 from the master, it's not pinged. Okay. So the communication is not done at this moment of time. But as I told you that they are in the same VPC, they are in the same network actually. So technically they are able to talk with each other, but they are not. The reason is very clear, the security group. So if you look into the security group, the one which is associated with all these machines, that security group do have only port number 22 open. So this is the security group. So currently these machines are in the same VPC, same subnet, but they are not able to ping with each other. The reason is the security. Okay. So here what I will do it, I will go to the edit inbound rule. I would say add rule. There is a rule for ICMP. Okay. I would say that I want anybody to, which is the part of this security group, they are able to ping with each other. So within the security group, this ping should be acceptable, not from outside. Okay, so I would say so. Now if I go ahead and try to see this, I am able to ping with each other. Correct? So the network communication across your machine is already there, but security group won't allow you to do that. I just enable the rule inside the security group that all ICMP traffic, okay, with all port number within the security group. I would not say source from anywhere. I said who is the part of this security group, only they are able to ping with it. So this is the same security group ID I mentioned for this particular group. This is a rule ID and this is the security group ID. Remember, this is a very, very tricky part. Correct? I said okay. So currently, am I able to ping? Yes, you can ping worker 1, you can ping worker 2, no problem. Even though if you go to the worker and if you try to ping this master also, it's pingable. If I go to the worker 1, ping, it's completely, the network communication is successfully done. Correct? I said okay, that's nice. Now what is the next part? So now we will go to the documentation of the Kubernetes and we will see what things needs to be done on these machines. So if I go here, okay. So this is the documentation links. This is nothing but kubernetes.io/docs/setup. Now this is the documentation link provided by the Kubernetes where we are actually going to understand how to do the installation. Now there is a production environment options are given. So we are supposed to go to the production environment. Okay. Now here the complete documentation that if I want to set up the Kubernetes cluster for a production environment, what setups are supposed to be done, that is completely mentioned over there. correct? Now here there are few settings which I know that has to be done on your all machine. And fortunately, this is a Amazon Linux machine. This is already done by your cloud provider AMI image. The first setting is the swipe space should be disabled inside your all workers and master. It is by default disabled in Amazon Linux machine. So if you execute a command called as free, you would be able to see the swipe space is already 0. By default, any instance, if you are launching on the top of AWS, the swipe is disabled. Okay, swipe space is not given to your machine. If you want to give the swipe space, you need to add the swipe space later on. Correct? Second, very important setting, there is no firewall D application at all. So if you can check, normally we need to turn off the firewall on every instance. But here we don't have any machine level or instance level firewall. What we have something called as security group for that. So we have a security group, but on the machine, there is no firewall package installed explicitly. So if you type the command called as systemctl stop firewall D, but he said there is no service because firewall D is an application which is actually running the firewall on the machine level. That is not installed here because you have a security group. Another very important setting on the machine is called as SE Linux, Secured Enhanced Linux. Now by default, that Secured Enhanced Linux is also permissive on Amazon instances. So if I execute a command called as get enforce, you would be able to see it is already permissive. So you don't have to do the setting, all these three settings on this machine at all, because this is basic fundamental settings which is already there. Then what settings are available, that we will see in the documentation. So if you go to the documentation, now what is the first documentation which we are going to follow? So we are going to follow the documentation is called as container runtime. So here container runtimes. Okay. Now this is very important documentation where all the installation steps to install container runtime on all the machines would be given by the kubernetes.io. How to install supported container runtime. So you would be able to see these are officially supported container runtime given by Kubernetes. Now officially Docker engine is not directly supported by the Kubernetes, but Docker community and there is a Mirantis company combinedly comes together and they started developing the drivers for Docker to work with the Kubernetes. However, we are planning to use Containerd as our runtime environment, which is very stable, open source product, which is very lightweight and very good to work with the Kubernetes. So here the step-by-step installation procedure is given that how to install Containerd. But remember that before you install any of these 4 container runtime, whatever you are going to select, there is a prerequisite. So that prerequisite over here. So there is a few kernel parameters with respect to networking. You are supposed to enable it. Now this is the kernel parameter. Now I don't want to discuss about what these kernel parameters are. The documentation is given the explanation what is the meaning of it. Okay. I literally copy the command as it is from here. And I just need to execute this command on every master, worker number 1 and worker number 2. Copy paste. Okay. Now here I need to apply these settings without rebooting your machine. So I will execute the second command from here. So I will apply it. I will apply it. I will simple. Now what this parameter do? It's clearly mentioned by default. Linux kernel do not allow IPv4 packets routed between the interfaces. Okay, so IPv4 packet cannot be routed between the interfaces. So I need to allow that. Okay, so that is the setting which is required. Now why we required it, we already discussed in the training why we require that particular part to be. But this is mandatory. Whether this setting has been successfully changed across the machine, this command is given to see you the parameter. The parameter is 1. By default this parameter is 0, but right now this parameter is 1. So I simply go to the worker number 2. I just confirm this parameter is successfully changed to 1. Correct? Even though if I reboot the machine, once again the parameter is actually stored into the file, kernel parameter file. So even if I reboot that particular machine, the kernel parameter written into this file, he will read that parameter and set it for runtime also and set it for reboot also. Correct? So this is a very interesting setting which we are supposed to do it. Then a lot of information about C group drivers we discuss. What is a systemd C group drivers are available. Okay, we don't want to discuss in this video because we just want to understand how this entire setup can be running on the top of the cloud. Now here I need to install the container D over here, so proper documentations are given over here. So if I click onto this documentation, that will go ahead and tell you to install container D on your system, follow the instruction. So if I open this documentation, this particular GitHub page will open. Okay. So when you open this GitHub page, multiple installation methods are given. The basic installation method is from the official binaries. This is the recommended method if you are going for production environment. Okay, so this is the step-by-step procedure given by the containerd documentation, that how you can install containerd binaries directly from their original project. Correct? But here there is a second very simplest option which we can use it also, that I can install this particular binaries from your apt-get or dnf package. But clear cut, there is an instruction given. The containerd package in dem or rpm format are distributed by Docker, not by containerd project. So remember very carefully, if you are installing the installing the binary from the containerd project, this method is recommended. Okay, from the official binary. However, we are talking about second option, which is very simple and very reliable for testing purpose, that containerd is given in a rpm format or debian format only by Docker. So Docker repository give you containerd package in a rpm format. So you can install that particular package very in a simple way. Correct? So if I click on this particular web, it is going to open the Docker dot page over there, where they are going to instruct you how to install Docker engine on CentOS machine. Now, do I install Docker engine over here? No, I am not. However, I am using this repository to install only containerd.io. I just want to install this repository on all 3 machines. There is a slight change you are supposed to do it, because this repository has been created for your specific CentOS and we are using Amazon Linux. So there is a conflict. So we are supposed to do some changes. However, we do not install the Docker at all. We are only taking containerd from this particular. So what I will do it, I will copy this command to add the repository to all my machines one by one. So I will go to the master. I will add the repository. I will go to the worker 1. I will add the repository. I will go to the worker 2. I will add that repository. So I am just adding that repository to every worker and master. Then I will go to my worker actually. Okay, just worker. Sorry, I will go to the master. Okay. Now I will go and open that repository because I told you this is a Amazon Linux. This is not my CentOS. So if I open cat etc /os hyphen release, this is actually Amazon Linux. The repository which I have added to install containerd, that is a CentOS. Correct? So I would like to do some changes into that repository file. Correct? Now what changes I want to do it? So I will open the file vi etc yum.repos.d, and there is a file called as docker-ce.rep. I open this file, and what change I need to do it under the first repository docker ce stable. Here, wherever it is mentioning the release version, here you just need to change it to 9. So I'm directly providing the CentOS release number 9 over there, because for 9 only the containerd package is available. So I just want to do that changes, save the file. Now I would like to repeat the same changes to worker number 1 and worker number 2 also. So I will go to the worker number 1 at this moment of time. I will open the same file. I will go to the line number 2, and where I am getting release server, I just replace that line with number 9. I would go ahead, save this file. Okay. I will go to the worker number 2. I will open the file. I will go to the line number 2. Here, release server. I will remove it, make it 9. Okay. I will go ahead and save. Correct. So yeah, I have done that particular change to every machine. Now I just want to install containerd.io. So if I say dnf install containerd.io -1. Correct. So if I install it, now I am install it on the master machine. Okay, so you can see it is successfully install it over there. If I do not mention that option, he tried to go for Amazon Linux repository on the Docker. So that repository is not available for the Docker side. You can see I'm installing containerd.io 2.2.4. Okay. Similarly, I need to go to my worker number 1, and similarly I need to go to the worker number 2 also. So I should install containerd.io on all 3 machines, including master and worker. So it's done on the master. It would be done in worker number 1 and worker number 2 also. Now once you have installed the containerd successfully, there is one more things which is available in the documentation. I will close this documentation because I don't require anything. I need to go down this page, and there is a advanced topics are available under the containerd documentation. Under the advanced topic, there is a command given by documentation that to configure default setting for the container. See, containerd is referring config.toml file. Now I want to generate default settings for containerd and save that default setting into the config.toml file. Currently that config.toml file is empty, but I would like to retrieve all the default setting of the containerd and store it into this config.toml file. So I will copy this command and I would save this particular command to every machine. So by default, every machine will generate all the default setting for containerd and save it into this config.toml. Correct? So right now, if you go to this config.toml file, sorry, I should change the location. It should be containerd config.toml. You would be able to see these are my default settings. Now, if I try to open this file before I executed that command, I would get almost empty file. These all parameters is not there. But after executing that default settings, all these default parameters are stored into that particular file. Now, why we require this? Because if you go to the documentation, now I don't require this documentation anymore. Here, the documentation is clearly mentioned that to use systemd C group driver in configurd with run C, set the following containerd version. So technically, there is a parameter inside that config.toml file. That parameter is called as systemd C group. Now by default, that parameter is actually false, and I would like to change that parameter to from that config.toml. That's the reason we generate that config.toml default parameters, because we want to do this change. Correct? So if you go to directly the line number 109, I know that line number exactly where this parameter is available. So you would be able to see systemd group C group is actually false. Correct? Now we would like to make it true. Now I am doing this setting on the master. Correct? So I have to save this particular setting. Now I need to do the same setting on all my worker 1 and worker 2. So I will go to the worker number 1. I will open it. Go to the line number 109 directly. I will go here, change it to true. I would save the file. Once again, I will go to the worker number 2. I will open the file, go to the line number 109, change that value, save the file. Correct? After you have done that changes into that file, the last thing what I need to do it, I need to start the containerd service with whatever changes which we have done in config.toml file, and I just need to enable this service. Okay, so I would say systemctl start containerd systemctl enable container. That's it. So I just want to go to my worker number 1, systemctl start containerd systemctl enable container. Okay, that is started. Just want to confirm systemctl status containerd. Just to check, confirm. You would be able to see containerd is active and running on worker number 1. I would say systemctl start containerd systemctl enable container. Okay, so all the necessary settings for my containerd is done. So I successfully installed containerd as a runtime on my machine. Now I will go to the installation of Kubernetes deployment method. Okay, now I am going to install the binary called as Kubeadm, because Kubeadm is the binary that will help us to create the cluster. Not just to create a cluster, to manage the cluster is also done by the utility called as Kubeadm. So you would be able to see there are 4 different methods are given by Kubernetes to create a cluster. Now the basic method which we are going to use is called as Kubeadm. So I will go to the Kubeadm method. Okay. Now here inside the Kubeadm method, all the documentation with respect to the Kubeadm is given over here. Now I would like to go to the documentation number 1 first. I need to install Kubeadm first on my machine. Okay. Then I will go ahead and create the cluster with the help of Kubeadm method. So you would be able to see this is the installation documentation of the utility called as Kubeadm. Now here we would be able to see the minimum requirement: compatible Linux host, 2 GB RAM, okay, 2 CPU, full control network connectivity. Now this is very important. Certain port on your machines to be. Now here if I click on it, there are some required port numbers which needs to be open. Now you would be able to see the port number 6443, 2379 to 2380, 150, 10259, 10257. These ports needs to be open across your machines. Correct? If you do not open these port numbers, your traffic will not be run across the workers and master. Correct? So what I need to do it, I need to go to the security group, edit inbound rules, and I need to add the rule to open this all the port numbers which is given over there. For number 6443, now this is supposed to be open on a control plane. Control plane means master machine. Now technically our master node and worker nodes are in the same security group. So I don't need to put it into different security group. I have to do it in the same security groups over there. So I need to open this all the port numbers. Okay. So but for a training purpose, what I will do it, I will add the rule. I would say all TCP traffic should only be allowed if you are within this security group. Okay. So this is all TCP traffic, not from outside. Within that security group, across the machine is allowed. But in real life, I told you this is the list of the port numbers are given. You are supposed to open the port numbers for master machine and for your worker machine separate. Correct? But for our to save our time, we will open all the TCP traffic from 0 to 65,000. But what is my condition? Condition is that if you are supposed in the same security group, means your source of the machine should be in the same security group. Okay, so that is very interesting way around to handle it. Okay, I will go back to the documentation. Now in this particular documentation, multiple things are given over here. That means how to check the RAM, certain port number, full network connectivity. Correct? Now let's go to the full network connectivity. If you go to the full network connectivity parameter, okay, there is one more thing which we have to check. Full network connectivity. Where is that? Check your OS version. Okay. Full network connectivity should be mentioned over there. Okay. Full network connectivity. Now I will tell you what you mean by full, because that is not documentation. Now there is a smart change is available. Now from my machine, if I try to ping my worker with their IP address is pingable. But if I try to ping by their name, it's not pingable. So in full network connectivity, there is one more parameter is also available. That means your self name resolution should be done. Means my machine able to talk with each other by their name. Now here we can take the advantage of Route 53 service provided by Amazon, which is a DNS service, or we can put the entry of all these machine into the etc/host file. So what I will do it, I will first of all check what is the IP address of my master machine. So this is my master machine. So I will go ahead. So this is the IP address. The name of the machine is called as master. Similarly, I will go to my worker. What is the IP address of the worker? The IP address of worker 1 is 192. I will go ahead and this is my worker -1. What is the IP address of worker 2? I will go to the worker 2. What is the IP address of worker 2? The IP address of worker. So I will put the entry of these three machine to every machine into etc/host file. So here, if I open etc/host file, this is the file for local name resolution. So I will copy paste these three entry to every machine, not just on the master. I need to copy paste this machine, sorry, this entry into worker also, etc/host file. Go to the worker, vi etc/host file. Okay. Now if I do this entry, I don't require any DNS server to be available. I would be able to resolve the name by etc/host file. So you can see that my master is able to know worker 1 and worker 2 very closely. So this is called a self-name resolution. Now remember that here if they are talking about full network connectivity, that is definitely the pingable network should be there. Plus your host name resolution should also be managed either with the help of DNS or either with the help of etc/host file. So we have created that entry. Now technically all these prerequisites are now okay because I do have a full network connectivity, 2 CPU, 2 GB RAM, proper network unique name, MAC address, port numbers are open, everything is configured properly. Okay, now I just want to make sure the necessary component to get installed. Now I need to install three utilities: Kubeadm, kubelet, kubectl for all my machines. Okay, these three utilities supposed to be installed over there. Correct? Now you need to make sure that you would get a proper documentation over here that if you want to install these three utilities, I will go to the Red Hat based distribution. Okay, because that is something which we are using as an Amazon Linux over there. So you would be able to see this setting is already done, that we already have the setting called as permissive. So you don't have to worry about that. Okay. After that, you would be able to see step-by-step documentation how to install kubelet, kubeadm and kubectl utility. As I told you, kubeadm is a cluster manager. Kubelet is a very important process to be running on all workers and master. There is a special responsibility for that. And kubectl is a client utility. It's a client utility to connect your cluster. That's it. So what I need to do is I need to copy this entire block of adding repository and put it into my master, put it into my worker number 1 and put it into the worker number 2. So I am adding the repository to all my machine to install these three utilities. Correct? After that, I will simply copy this command Okay, I think I'm using DNF5, so I will copy this command and install it all three utilities on all three machines. Okay, so that will install all the necessary utilities. Okay, after that you just need to make sure that the kubelet process supposed to be enabled. Okay, I just want to make sure that it should be enabled. Okay, that's it. So that will install all the necessary component for your Kubernetes. Now once you have done this, there is another documentation is to create the cluster with the Kubeadm. Now you have just installed that utility. You have not created the cluster yet. Okay. Now to create the cluster, once again, before you begin, there are few prerequisites which you need to check. Correct. Now after you have done that prerequisite check, you can please refer this documentation very carefully. And to create a cluster, there is a very simple command which you need to execute, that is called as kubeadm init. Now remember, whenever you are creating the cluster, your initialization is happening only from master. Till so far, I am telling you to execute the command from master as well as from the worker. But whenever you are going for the initialization of the cluster, that should be only and only done from the master. So there is a very simple command which is given by the documentation, and you have to execute that command only from the master. That is called as kubeadm init. Now this particular command will initialize your cluster. He will start creating your cluster. Now this command is having multiple arguments. If you execute --help command, there are multiple argument I can pass inside your cluster over there. You would be able to see there are multiple argument it is accepted over here. So you are supposed to pass the argument to the component. You are supposed to pass the argument to the phases. Correct. So there are multiple customization I can do it while creating your cluster. Correct. But here I do not want to create any customization. I would like to make it very simple. Kubeadm init. I will press enter. I would like to make sure that all the settings would be default. Doesn't matter. Correct. So it will take 1 minute to create your cluster. Less than a minute actually. Done. Your cluster is ready. Now you would be able to see there is a kubeadm join command is given over here. So I will copy this join command and execute this join command on the worker 1 and worker 2 respectively. So I will add the worker 1. I will go to the worker number 2. I will add worker 2. Okay. After you have added successfully worker 1 and worker 2, what you can do it? You can execute this particular command. As I told you, config is a configuration file which is required to connect to your cluster for the first time. This configuration file is actually created by the cluster by the name called as admin.conf on the master machine under this location. Now what you need to do it from any client computer. If you want to connect to the cluster, you need to have this particular file available over there. So currently I'm using master machine to connect with the cluster. So I can execute this command on the master. So master will connect to the Kubernetes cluster with this config file. So I will go ahead. So I will copy paste this command as it is. So you can go ahead and say kubectl get nodes. Now currently your nodes are in the not ready stage because as I told you, technically your master components are actually working fine. So if I say kubectl get pods minus n cube hyphen system, you would be able to see very clearly my all Kubernetes cluster components are successfully running. My cluster is completely up and running fine. The only reason why I'm getting some pods are in the pending stage because as I told you or as I discussed in the training, Kubernetes don't have native networking drivers at all. Currently, whatever pods which are running with networking with IP address, you can see that those pods are sharing the host IP address of your workers and masters because I do not have networking drivers by default. But if I want to install networking driver, first I need to create my cluster. Without cluster, I cannot install the networking drivers on the top of it. So all the necessary component, which actually the component of your architecture, those all components are running as a pod, and those pods are directly sharing the host network identity. That's the reason this API server, controller, etcd, scheduler, these are pod. But look at the IP address of the pod. Those are the IP address of that machine because these pod are sharing host network feature. But if you can see that core DNS is pending because these are normal pod and these are pending because there is no networking service available. Now here there are multiple networking drivers are available. Now one of the driver is called as Calico. Now we are installing Calico on the top of the Kubernetes cluster. Now we are using AWS cluster to create, sorry, AWS cloud to create a cluster. So this is almost on premises. Okay, the only thing is we are not using on premises infra, we are using infra which is coming from the cloud. But ultimately this is actually act like a on premises. So here the proper documentations are given. If I want to install Calico networking drivers, how do I do that? Now currently there are multiple methods are given. One is the operator based method. Okay, manifest based methods are available. We would like to make it very simple at this moment of time. I will go to this last option called as manifest. Okay, let me refresh this page. I think it's hanged. If I go to the manifest, you would be able to see install Calico with Kubernetes API data source 50 nodes or less. So you will get this documentation calico.yaml file. I will copy this command. I will go to the master. I will download this calico.yaml file. Now this calico.yaml file contain all the necessary component to get installed over there. Correct? I just want to check only one component over here that is called as, okay, so that is something which I need to check it because Calico is also working in a different modes actually. One is called as IP and IP mode, vxlan mode and bird mode actually. So I just want to confirm that by default in which mode it's running. But let's do one thing. I will go ahead and say kubectl create -f calico.yaml. The moment I press enter, all the necessary component which is required for Calico networking driver will get it installed over here. Correct? So you can see this. Now once you install the Calico networking driver, you can go ahead and say watch kubectl get pods minus n cube hyphen system. You would be able to see some Calico nodes are started creating over here because you install Calico on your cluster. Now on the Kubernetes cluster, whenever you want to install anything, that means you are installing the respected pods for it. So you can see right now, after installing the Calico, my Calico are successfully running and ready stage. Okay. Now, once I install the Calico, if I say kubectl get nodes, my node was in a not ready stage. Right now it is in a ready stage. Now one thing you can carefully check over here. Earlier my core DNS pod was in a pending stage, but right now you can see that my core DNS pod is in a running stage, and you would be able to see my core DNS pod got this IP address. Now who gave this IP address to this pod? My Calico. Correct? My Calico is giving this particular IP address to my pod. Now, if I go ahead and create any pod into the cluster for testing purpose, if I say kubectl run my pod hyphen hyphen image is equal to nginx, you would be able to see kubectl get pods minus o wide. You would be able to see my pod number, sorry, my pod is currently the container is creating. It has been scheduled to the worker number 1. Currently don't have an IP address because my pod is scheduled on worker number 1. Now he might be doing some activity. Right now you can see my pod is in a running stage. It was in a container creating stage earlier. It does not have an IP address. Now it does have an IP address. Now who gave this IP address to this pod? Calico. Correct? And it is running on worker number. Now if I say curl this IP address, I am not able to communicate. Remember, this is very, very important. So technically I am technically available on my specific cluster. I am trying to access this pod with the help of the pod IP address. So technically Calico should help me to go and reach to this particular pod URL. Now this is very interesting. This is very, very common mistake people are doing. Now you can see over here, I would copy the same IP address and now I will go to the worker number 1 where this pod has been scheduled. Okay, now this pod is running over here. If I say CRI CTL, okay, if I say curl this IP address, I am able to access my application only from that pod where it has been scheduled. But if I try to access the same pod from the master machine, it's not accessible. Why? Technically, this particular IP address should be accessible anywhere because Calico helped me to reach to that particular pod. This is why Calico is installed over there. But Calico only allowed it to go to the worker number 1, try to access this IP address, you are able to access your Nginx. But if I try to do the same thing from the master, it's not possible. Why? Now Calico is installed. Calico should reach or Calico should send my communication to that particular IP address. But it's not doing it. Why? Now technically there are two problems over here. Let me figure it out the first problem. Now Calico node required UDP port number should be enabled. So what I will do it, I will open the edit inbound rules. I will add the rule. I would go ahead and say all UDP only from the same security group. I would say save. Correct? I have done this. Now I will once again try to communicate it. It's not happening. Okay, am I able to ping that IP address by the way from the master? I'm not able to ping it also. So problem is not just a UDP connection, there is something else. Now remember guys, whenever you are creating a Calico or you are installing the Calico, you are technically actually going to check the mode for that Calico. So if I go here, this is the command which I am getting it. If I open this, you would be able to see that currently the Calico is running with the mode called as ipipMode, which is saying always. Correct? Now let me tell you, ipipMode is not compatible for VPC. If it is only compatible if you are running in an on-premises cluster. ipipMode is not compatible if you are running the cluster on the top of AWS, because VPC does not support ipipMode. It will only support vxlanMode. So what I need to do it, I need to turn off this mode and turn on this particular mode. Correct? So what I will do it, so this is the simple command which I would like to do it. I would like to patch the settings. Okay, so I will say copy and execute this particular command over here. Now it is successfully patched. Patch means I updated the values over there. Now if I go ahead, now look at here, ipipMode is never, earlier it was always, and vxlanMode is always, right. Earlier it was never. Now if I go ahead and try to ping, you are able to get the reply. Okay, and if you try to execute the application with the curl command, it is accept. So remember that your this mode called as ipipMode should be disabled and vxlanMode should be enabled inside your Calico if you are running the Calico on the top of the cloud. Correct? Otherwise, what will happen, on which particular pod that particular, on which particular worker, if that particular pod is scheduled, if I say kubectl get pod, on from worker 1 only this particular application is accessible. It cannot be accessible from the rest of the workers and master. So that is the problem. The problem is your specific mode. Now that particular mode is turned on. If I want to disable this UDP, I turn it on earlier. Now this UDP is also mandatory because vxlanMode required some UDP port to be enabled. If I turn on ipipMode vxlan and if I disable that particular UDP port number, okay, then also vxlan will not work. So you have to change that mode to the vxlanMode, as well as you are supposed to turn on the port number, all the UDP port number only from that security group. Now there is a port number 4879 actually required for vxlan, okay, but I, for temporary purpose, I required all UDP and TCP port number available only within that security group. Okay, so currently if you can see right now my cluster is up running successfully. If you can go ahead, okay, I'm able to run the cluster. So if I say kubectl get pods minus n cube hyphen system, I'm able to run everything right now. My, if I say kubectl cluster hyphen info, my cluster is healthy. If you can see kubectl get nodes, my nodes are already, Calico is placed. Calico is able to successfully do the communication across the worker, no problem at all. Correct? So this is how you are supposed to configure your cluster on the top of your AWS cloud provider. Now almost similar settings would be available if you are using Azure cloud. Same challenges would be available. Networking, you have to do the networking properly. Definitely IP, on IP mode for Calico is not supported over there also, so you have to change it to vxlan. Okay, once you have done this particular cluster in that way, you are good to go. Okay, so this is how you are supposed to create the cluster. Thank you very much for watching this video. Bye bye and take care.